Okay, so I have to define sequences and series in order for you to understand sequences, because these concepts often get confusing, and because those definitions always come together in any study of calculus. Okay, so a sequence is when you take and you make a list of numbers. So 1, 1/2, 1/4, 1/8, 1/16. You can figure out the pattern yourself on this one. That is a sequence. A series looks very similar, but you add the terms of the sequence to get the series. So a series would look like this instead. Okay, so if you are adding up the pieces to get to a final limit, then that would be a series. And in fact, you can probably figure out that this limits to 2, whereas this limits to 0, right? Because the individual pieces are going down, 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 down to 0, but the total sum is going to 2. So be careful of your terminology. Okay, so all the notation is just to get you thinking about how to construct these. You can look at S sub n and think of it as like f of n. You can write it this way. Is equal to f of n is f of n minus 1 plus 2, and f at 0 is 3. So it's really equivalent notation to functional notation, but we're using this subscript as the argument of the function. So that's all that's going on. So how would you find, for example, the underlying function, which would be good only on integers, non-negative integers? Well, how would you find the function that this is? So you would say, well, f of 0 equals 3. F of 1 must be f of 0 plus 2, so it's 5. And pretty soon you're going to figure out that it's just going to be stepping by 2, stepping by 2, stepping by 2. And finally, you're going to say, okay, how can I write this in a cleaner way? Then you can say, you can use an x or an n, whatever you like. F of n is equal to 3 plus 2 times n, right? And let's see if that works for what we have here. For example, f of 2 is 7. Is that correct? It's 3 plus 4 is 7, and so this is the process you would use for verifying this. And then you would say n is a non-negative integer. Okay, obviously the function we've created might be valid in other places, but if you're thinking in terms of a sequence, you're thinking about a definite start to your sequence and a definite progression along integer values of n. So there's this sort of symbiosis with what we know about lines. This is essentially a line, but we're only thinking about all the points on the line. We're only taking a certain selection of points off of the line. Okay, so that's the relationship between that line function that we just found versus the points that make up the sequence that we just solved for. Here's a super easy one. If we have a starting value of 1, and then we multiply by 2 each time, we get a simple progression, and then we could figure out that Sn is equal to 2 to the power of n. Okay, and that kind of thing can happen too. So those are two pretty classic types of problems. And then there's this classic one where we're just creating triangle numbers. So S0 is nothing. That means S1 is going to be 1. S2 is going to be 2 plus the previous one. S3 is 3 plus the previous one. S4 is 4 plus the previous one. And so on and so forth. And if you've never seen triangle numbers before, let me give you a formula for that. So triangle of n is just n squared over 2 plus n over 2, which might more easily be written like so. That doesn't mean delta n. That's just like a triangle of n. And the way I want you to think of it, here's triangle of 5. We're going to think about triangle of 5. Think of 5 squared, and I'm just going to take these black dots, okay? I want to take half of those And so if I take n squared and divide it by 2, it's these little black dots are going to get cut in half, and that would be pretty sad. They're going to get cut in half. So we want half of them back again, the ones that we lost when we cut, and that would be n over 2. So we're going to add those back in, and that's how we're going to get our triangle number. Okay, and then if you want, you can factor that numerator, whatever. Sometimes the way you might find the formula for triangle number is going to be n times n minus 1. And that's depending on what you're thinking of. Maybe you're thinking of this as being, I don't know, like 5. I don't know why you would do that. But anyway, both n times n minus 1 and n times n plus 1 are going to give you something you can divide by 2 and end up with some triangle number anyway. So this is just something to, this progression is something to be on the lookout for. Okay, so you have some questions in here about convergence of sequences. And for example, I'm just going to make one up. 4 plus e to the minus 5n. Does that converge? So you just put that into a limit context. You say limit as n goes to infinity of 4 plus e to the minus 5n. If you don't like n's, you can use x's. I don't care. If it helps you visualize this and think of this as the function it is, and you think, wait a second, that's just going to be 4 plus 1 over e to the minus infinity. 1 over infinity is going to 0. I didn't mean to put the minus and the infinity together. 1 over e to the infinity goes to 0, and so the limit is 4. Again, this is sloppy notation, but I don't expect you to be any less sloppy than me. I want you to focus on your comprehension. So again, if you're going to write this up in a journal, don't use that notation. But if it's just for your homework, that's totally fine. And the final questions ask you to plot the sequences and explain their behaviors. What I will recommend, and it says plot, I would say plot first by hand, and then before you do the quiz, try it on Desmos or Wolfram to see if you're right until you agree with whatever the technology says, and then go ahead and do the quiz. So there's no reason to sort of go in there cold, and you may as well get some practice with that before you commit to your answer. And I think that's a pretty straightforward worksheet. Hopefully you'll find it light and easy, and I'll see you in the next video.